We are going to look at trigonometry and all that we have done in class, a recap of it. So let me start with something you already know, an equilateral triangle where all the three angles are 60 and the three sides are equal. Right? I'll draw perpendicular from one of the vertices to the opposite side. Now we know that if a point is equidistant from the two ends of a segment, then this point lies on the perpendicular bisector. This is how you had done the construction of perpendicular bisector. So which means this point will divide the opposite side into two equal parts. It will also bisect the angle through which it is passing and make it 30 each. So what we now have after drawing the perpendicular is, I have a 30, 60, 90 triangle with the hypotenuse as A and the side opposite to 30 as A by 2. By Pythagorean theorem, I can find the third side, which will turn out to be root 3 by 2A. Now, any 30, 60, 90 triangle, you know, with whatever length of hypotenuse is going to be similar to this triangle. And by similarity, we mean the sides are growing in the same proportion. So even if I have the hypotenuse as 10 centimeter or 16 centimeter or 5 centimeter, the ratio of how the side opposite to 30 and side opposite to 60 grow will be in the same proportion as you are seeing here in this triangle, which means side opposite to 30 will always be half the hypotenuse and side opposite to 60 will be root 3 by 2 times hypotenuse. I'll similarly try to draw something about the 45, 45, 90 triangle. So if I have a 45, 45, 90 which is an isosceles right triangle with hypotenuse as A, then by the Pythagorean theorem we can find these two equal sides. If they are x, then this is how we write the Pythagorean theorem, which means 2x square is a square and x is a upon root 2. Again, if I take any 45, 45, 90, the sides are going to grow in the same proportion, which means always the side opposite to 45 will be 1 upon root 2 times the hypotenuse. So I'm trying to help you understand that angles and side opposite to it have some connection. And it is also easy to know if I have a triangle and I will try to think of it as a ladder resting on there's a wall and there's a floor and there's a ladder resting. If I have an angle that ladder makes with the floor, now if I start pushing the ladder towards the wall, you will see that the angle goes on increasing, right? Theta goes on increasing if I push it towards the wall. And when theta increases, you will see that this triangle that it is making, ABC, the edge AC will start increasing, AC will increase and BC will decrease, which means opposite side increases and adjacent side decreases. So the angle and the sides opposite and adjacent to it have some connection to it. Similarly, if I try to push the ladder away from the wall, do you see that theta decreases, which decreases AC but increases BC? So all I'm trying to show you is that in a triangle, angles and sides have relation to each other. And that's exactly what I showed you in the 30, 60, 90 and 45, 45, 90 also. And this is what is captured in trigonometry. So these relations were defined in the form of 6 ratios. So you have 3 sides. And if I want to find the reason ratio is because we know that in similarity of triangles, sides grow in the same proportion, which means I have to deal with ratios. 3 sides are written in ratio. Ratio means it's a fraction, so I need 2 sides at a time. And I'm arranging them because I have something in the numerator and something in the denominator. So from 3 sides, if I'm trying to arrange 2 sides, then the number of permutations that I get are 6. So that means I have 6 ratios. And how are these ratios defined? Well, I have sine of theta. In trigonometry, you will always see that as this. They don't write it as sine. And it is defined as opposite side upon hypotenuse. Now, all of these were defined in terms of a right angle triangle. So I have a hypotenuse, I have an angle marked, and with respect to this angle, I will have a side opposite to it and I'll have a side adjacent to it. So if for this right triangle, sine theta. So sine, all these ratios are defined for a right angle triangle. Cos of theta is defined as adjacent side upon hypotenuse, and tan of theta is defined as opposite upon adjacent. If you relook at tan theta carefully, I can divide the numerator and the denominator by a common term, which is the hypotenuse, which means the numerator would become sine theta, the denominator will become cos theta, and therefore tan theta is also defined as sine theta upon cos theta. So opposite upon adjacent is one definition, yes, but I can also write tan theta in terms of sine and cos. So these are the 3 main ones. Okay, so I have sine theta, opposite upon sine is opposite upon hypotenuse. I have cos theta, which is adjacent upon hypotenuse, and I have tan theta, which is opposite upon adjacent. So some people remember this as SOHCAHTOA, opposite upon hypotenuse, adjacent upon hypotenuse, and opposite upon adjacent. So these are our first 3 ratios defined. They're reciprocals because you saw that it's a permutation, right? Arrangement. So their reciprocals also have been defined. So this is called cosecant theta. The reciprocal of cos is called secant theta, and the reciprocal of tan is called cotangent theta. So let us first look at sine and cos and try to understand their relation. So I'll again move to this 30, 60, 90 triangle, and I told you that if I know the hypotenuse, then the side opposite to 30 is half the hypotenuse, and the side opposite to 60 is root 3 by 2 of the hypotenuse. Now if I use my definitions of trig ratios, sine 30 will be opposite side upon hypotenuse, opposite side upon hypotenuse, which means half. So sine 30 in any triangle, okay, will be half, because if I form a right angle triangle with 30, then the third angle will be 60, isn't it? Because sum of angles in a triangle is 180. So wherever there is a 30 and 90, the third angle is 60. So it's always going to be a 30, 60, 90 triangle, and therefore the ratio will always be half. Sine 60 is again opposite side upon hypotenuse, opposite side, and the answer is root 3 by 2. So that means sine 30, sine 60, these are fixed values. Even if the triangle is becoming bigger or smaller, the sides are growing in the same proportion, and because these ratios are ratios of two sides, they will have to be the same. So I'm using just the concept of similarity till now to tell you why sine, cos of an angle remain fixed, because they are taking ratios of similar triangles, because angles are the same. Sine 90, well, you may say it's opposite side and hypotenuse. Opposite and hypotenuse are the same. So is it 1? Well, actually yes, and we can define it in one other way, but that's true. Let's define cos. So cos 30 is adjacent side upon hypotenuse. So cos 30, if you look at the adjacent side, is root 3 by 2 upon hypotenuse, which is root 3 by 2. Cos 60, okay, look at your triangle, adjacent side upon hypotenuse is half. Cos 90, well, as soon as I look at 90, I don't know which one is the adjacent side. Both a by 2 and a root 3 by 2 are adjacent to it. So which one should I take? For now, I will leave it undefined because I'm not sure what to do. But one thing I want to tell you. In a triangle, there's hypotenuse. For a given angle, there is opposite side and there is adjacent side, right? Now we know by Pythagorean theorem, opposite side square, I'm sorry, let me correct that. Opposite side square plus adjacent side square is equal to the hypotenuse square. Which means opposite upon hypotenuse the whole square plus adjacent upon hypotenuse the whole square is equal to 1. But what is opposite upon hypotenuse? Well, it is sine of theta. And what is adjacent upon hypotenuse? Well, it's cos of theta. That means in every right angle triangle, if I define angle theta, sine square theta plus cos square theta should always be equal to 1. So the two ratios are sharing parts of the triangle, isn't it? So if opposite side goes on increasing, adjacent side will have to go on decreasing. Now if sine of 90 is 1, according to this rule, sine square 90 plus cos square 90 should be 1. If sine 90 is already 1, what must be cos square 90? According to this, cos square 90 should be 0, which means cos 90 is 0. In other words, in a right triangle, imagine theta is going on increasing, which means I'm pushing it. If it's like a ladder resting on the wall, I'm pushing the ladder towards the wall, right? The opposite side is like the wall and the adjacent side is like the floor. As I do that, theta goes on increasing and starts going towards 90. I know it can never become 90 because then there won't be a triangle. But as it moves towards 90, opposite side starts increasing. At one point, it will almost be equal to the hypotenuse, and at that time, adjacent side will be 0. So that's another way to think of that. As the angle goes on increasing to become towards 90, sine value is going on increasing because sine is opposite upon hypotenuse, whereas cos value is going on decreasing. Will it ever become 0? Frankly speaking, no, because theta cannot be 90. But that's how we look at the values, that the maximum it can take is that the opposite side is same as hypotenuse and there is no adjacent side. right? So that's how we understand cos 90 and sin 90. Okay, let's look at the 45, 45, 90 triangle and again define our ratios. So I have hypotenuse, I have this is how I define. So sine of 45 is opposite side upon hypotenuse. If I divide, I get 1 upon root 2. Cos of 45 is adjacent side upon hypotenuse. Again, 1 upon root 2. Both are equal, which makes sense because it's an isosceles right triangle, so opposite and adjacent side have to be same. Again here, I am not going to define sin 90 and cos 90 because we've already defined that. So now let me rewrite these values, okay? Theta 0, 30, 45, 60 and 90. Well, you may say you have not yet defined sine and cos for 0. Let us understand that. So we had said when the ladder is resting against the wall and if I start pushing the ladder towards the wall, theta will go on increasing, sine will go on increasing and cos will go on decreasing. Now imagine the other side. I have the ladder resting against the wall, but this time instead of pushing it towards the wall, I'm pushing it away from the wall. So it's slipping along the wall. Now in this case, adjacent side will go on increasing and opposite side will go on decreasing. Till what point? Till the point where theta is almost 0, which means the ladder will almost fall on the floor. And in that case, adjacent side will almost be equal to the hypotenuse and opposite side will almost be 0. Again, when ladder falls on the floor, you may say there is no triangle. Correct. So I can only go towards reaching 0. But when that happens, the same logic as cos and sin 90, cos of 0, which means the adjacent side, becomes maximum and sine of 0, opposite side, is becoming minimum. Sine and cos are a fraction. Fractions can maximum be 1. Well, you may say, what about an improper fraction? Here it doesn't make sense, right? Improper fraction. Because I have a triangle where hypotenuse is the longest side. And so adjacent and opposite have to be less than them. So a ratio of these sides will always be maximum 1 and anything less than 1. Now let me consolidate the values. Sine of 0 is 0, cos of 0 is 1. Sine of 30 is half, cos of 30 is root 3 by 2. Sine of 45 is 1 upon root 2, cos of 45 is also 1 upon root 2. Sine of 60 is root 3 by 2, cos of 60 is half. Sine of 90 is 1 and cos of 90 is 0. Okay. Pay attention closely to this. Sine of 30 and cos of 60 are the same. Sine of 60 and cos of 30 are the same. Sine of 0 and cos of 90 are the same. Sine of 90 and cos of 0 are the same. So sine of an angle and cos of its complementary angle. What is the meaning of complementary? If theta is the angle, 90 minus theta is the complementary angle. So sine of an angle and cos of the complementary angle are equal. That's why it is called cosine, complementary sine. Is this true for all angles? Yes. If I know sine of an angle, cos of its complementary angle will also be the same. Does it make sense when I look at the triangle? Actually, yes, because you know, opposite and adjacent are related to each other because hypotenuse, if it doesn't change, that doesn't change. If angle is increasing, opposite side is increasing, adjacent is decreasing. If angle is decreasing, adjacent side is increasing, opposite is decreasing. So sine and cosine will be changing in proportion, not directly proportional, not inversely proportional, but in some kind of a proportion. And that's one relation we want to know. So we have looked at two relations till now, okay? One is tan theta is sine theta upon cos theta. Another is sine theta is cos of 90 minus theta. Okay. What about the other ratios? The other ratios, I don't need to know. Once I know sine and cos, I can define everything, right? Because tan theta is sine upon cos. So if I know the values of sine and cos, I can find this. Secant theta is 1 upon cos theta. Cosecant theta is 1 upon sine theta. And cot theta is 1 upon tan theta. So I will know all values once I know sine and cos. So I don't need to define anything else. Okay. Let me now look at why the names sine, cos, and for that I'm going to move to a unit circle. What is the meaning of a unit circle and why? First of all, I'm going along a circle. So understand, if I have a point and I'm trying to move along an angle, okay, I'm making an angular movement. Angular movement means I'm fixed to one point and I'm moving. Whenever I'm fixing a point and trying to move the other point, I always move along a circle. It's a circular movement. So when I'm forming an angle, I'm actually moving along a circle. And that's why, if you know, you measure angles with a protractor, which is a semicircle. Because angle movement is circular movement. Also, so let me draw a circle. I know it doesn't look like a very good circle, but that's fine. Whenever I'm moving along a circle, I'm also forming a triangle. In fact, a right triangle. So somewhere the right triangles are inscribed in a circle. And that's the reason we are using this concept of circle to define or to understand the ratios better. Okay. Look at this circle. So if I have my radius of the circle as 1, that's why it's called unit circle. So 1 what? Is it 1 centimeter? Is it 1 feet? Is it 1 inch? What is 1? Well, 1 is normalizing the radius. Like for example, if I draw the radius of 8 centimeter, I may say 8 centimeter, let 8 centimeter be 1 unit. So I'm scaling it down to 1. So everything else on the circle will be scaled accordingly. If I draw a circle of 10 centimeter, I may take 10 centimeter is equal to 1 unit. That's the meaning of unit circle. So it's not about 1 centimeter or 1 inch. It's making the scale of that radius to 1. Like how you used to scale on a map, same way. Now that we understand the meaning of unit circle, let me draw something. So I have a unit circle with origin as the center. The radius is 1. So what will this point coordinates be? 1, 0. I am going to mark a point on this circle whose angle is theta with respect to the positive x-axis, and say it is intersecting the circle, it's meeting the circle at point A. So if A has coordinates x comma y in the Cartesian plane, then we know this side is x and this side is y, and my hypotenuse is 1 because I define it as a unit circle. Now let me draw a tangent to the circle at A. Okay, it's meeting the circle only at one point, and then it is intersecting. So let me erase this. Let me only write the points. It intersects the circle at B here. It intersects the circle at C here. I'll also name this point E here. And this is a right angle triangle. Okay. We also know that radius is perpendicular to the tangent. So I have a right angle here as well. Okay. Now in this small triangle, in the triangle, and this is O, in this triangle AOE, I have sine theta as opposite side upon hypotenuse, which is y upon 1 equal to y. I have cos of theta as adjacent side upon hypotenuse, which is x. And I have tan theta is opposite side upon adjacent side, which is y upon x. I have secant theta, which is 1 upon cos theta. I have cosecant theta, 1 upon sin theta. And I have cot theta as adjacent upon opposite. So all ratios have been defined in terms of x and y. What is x? X and y are actually the coordinates of this point on the unit circle. And I could get all the ratios in terms of x and y. So are you seeing the use of the unit circle? If I have a point on the unit circle whose x and y coordinates are known, I actually know all the ratios of the angle that the point makes with respect to the x-axis. Another interesting thing is, look at the triangle. Look at triangle AOE and triangle BAO. BOA. AOE and BOA. These two are similar triangles. Both are right angle triangles. Both have one angle equal. So the third angle will always also be equal, and therefore they are similar. If angles are same, then triangles are similar. So sides will be in proportion. So adjacent, so it's for theta, y upon x is like opposite side upon adjacent side. In the bigger triangle also, theta I should have opposite side upon adjacent side. So opposite side upon adjacent side. So AB is y by x. But what is AB? AB was, y by x was defined as tan theta. So that means this segment AB is nothing but tan of theta. So this segment AB is tan of theta. So tangent of an angle is actually a segment on the tangent to the circle. So the name tangent is justified. Interesting. Continuing with the similarity of the triangle, I have hypotenuse. So in the same triangle AOE, hypotenuse upon adjacent side, hypotenuse upon adjacent side is same as in the bigger triangle also, hypotenuse upon adjacent side. So what is OB? OB is 1 by x. Do you remember what was 1 by x? Well, 1 by x is secant theta, 1 by cos theta. So that means this segment OB should represent what? The segment OB should represent secant theta. Is this on the secant to the circle? Yes. Point B is a point external to the circle, and a line passing through B is intersecting the circle in two places. So OB is a part of the secant to the circle, and that's the name, so it's justified. So where are cotangent and cosecant? Okay, well, look at this other right triangle. So I'm going to again do similarity of triangles, but now with two other triangles. Look at triangle AOE. It is also similar to, if this is theta, this is 90 minus theta, this is theta. So AOE is similar to OCA. So again, let me write cotangent theta in the small triangle, okay? Cotangent theta in the small triangle is adjacent side upon opposite side. So x upon y. X upon y is adjacent upon opposite. In the big triangle also, can I look at adjacent upon opposite? Adjacent is AC and opposite is 1. So AC is x by y. That means AC is cotangent theta. So this side of the triangle is representing cotangent theta. And similarly, I can write cosecant is hypotenuse upon opposite side, cosecant, which is same as, so look at the bigger triangle, hypotenuse upon opposite side. So OC is nothing but 1 by y, which means it is cosecant theta. So this is cosecant theta. Again, is this a part of a secant? Yes, C is a point external to the circle, intersects the circle at 2 points. So that means it lies. OC is a segment on the secant. Why cosecant? Because if this is secant, then this is along the complementary angle. This is 90 minus theta, right? So complementary secant is what the other segment is, and that's why the name. So makes sense. So all my ratios are actually defined on the unit circle segments. That's the reason unit circle becomes important. If you also notice, let me redraw the circle. We have sine square theta plus cos square theta is 1. If I divide throughout by cos square theta, I'll get tan square theta plus 1 is secant square theta. If I divide this throughout by sine square theta, I'll get 1 plus cot square theta is equal to cosecant square theta. So I got another three statements which are true. So I have tan theta as sin theta upon cos theta, and then I have sin theta is same as cos of 90 minus theta, and now I have these identities. These are called identities, which means they are true for all values of theta. Excellent. You may pause if you are too exhausted listening and then come back. And I'm going to go ahead and start doing my unit circle, which doesn't look good. Let me redraw it. Bigger and better circle. Okay. So I know that in a circle I totally have 360 degrees. So my point A, which right now I was only looking at in the first quadrant, can actually move along any quadrant, right? Can be in the second quadrant, third, fourth. Let me say that A moves to the second quadrant such that it makes an angle theta in this way. Okay, essentially what angle is it making with the x-axis? A1 is making an angle of 180 minus theta with the positive x-axis. But when I do that, the right triangle that it forms is still similar to what it was forming in the first quadrant, which means I still have the opposite side. If this is y and x, I still have the opposite side as y, but adjacent side, though the value is x, it is now on the negative x-axis, so I'm going to call it minus x. Similarly, if A now moves in the third quadrant such that it again makes an angle theta, so let me redraw it. If it again makes an angle theta, you will see that I still have a similar triangle, but now I have the y value also along the negative and the x value also along the negative axis. And finally, if I draw a similar triangle, that means A moves in the fourth quadrant, making the same angle theta with the positive x-axis, then how much A has actually moved is 360 minus theta. Still the same triangle, y is negative but x is positive. Why am I really doing this? So all I'm trying to show you is the triangles that are formed when angles are moving in this form, 180 minus theta or 180 plus theta or 360 minus theta, the triangles that are formed, the right angle triangles, are similar looking to how it is in the first quadrant. Let us take theta as 30 degrees, for example. So the triangle that is formed in the first quadrant will be 30, 60 and 90, which means if hypotenuse is 1, side opposite to 30 will be half and side opposite to 60 will be root 3 by 2. If I move to an angle 150, what is 150? 180 minus theta, 180 minus 30. I will make a similar triangle as that of 30, 60, 90. If I have angle of 150 with the positive x-axis, I'll still make an angle similar to that in the first quadrant. If hypotenuse is 1, I will still have opposite side. I'll still have the opposite side and adjacent side of the same value. However, Now I know that the adjacent side is along the negative x-axis, so minus. Same way, if I move such that I move how much? I move 180 plus 30, which means theta is equal to 210. I will still have a 30, 60, 90 triangle, which means opposite side and adjacent side are still the same. However, now we are in the third quadrant, so both x and y values are negative. Same way, if I make an angle of 330 degrees, I will still have a 30, 60, 90 triangle, which means opposite side and adjacent side are still going to be the same value, but now y value is negative and x is positive. So all I'm trying to tell you is sine of 30 is same as sine of 150, because do you see 30 and 150, that's the same, is same as minus sine of 210. Value is same but in the negative axis, is same as minus sine of 330. Same value but in the negative side, because the triangles that they are forming with the x-axis is still 30, 60, 90, but in the different quadrants. Same way, cos of 30 is same as cos of 150, but it is in the negative x-axis, is same as cos of 210, but also in the negative x-axis, is same as cos of 330. Will this happen every single time? Yes, you can try with 60 also. Look at it. Side opposite to 60 is always root 3 by 2, irrespective of which quadrant it is in, but the sign changes. Can I consolidate this? Yes, that means if I know the angle in the first quadrant, if theta is in the first quadrant, that means theta is between 0 and 90. How do I measure theta? With respect to the positive x-axis. Theta is in the first quadrant, and if I know sine theta, then I automatically know sine 180 minus theta in the second quadrant. I also know sine of 180 plus theta, but with a negative sign, because in the third quadrant. I also know sine of 360 minus theta with a negative sign. Same way, if I know cos theta, I also know cos of 180 minus theta, negative. I know cos of 180 plus theta, and I know cos of 360 minus theta. So let me write again. Let me fill the table again. Theta 0, 30, 45, 60, 90. I knew this till now. 0, half, 1 upon root 2, root 3 by 2 and 1. Cos is also 1, root 3 by 2, 1 upon root 2, half and 0. Now I also know this for other angles. Which other angles? If I know 0, I know 180 minus 0. Same value. Cos also same value but with a negative sign, because second quadrant. I know 180 minus 30. Same value but with a negative sign. I know 180 minus 45. Same value, cos with a negative sign. I know 180 minus 60. And I know 180 minus 90, which is same as 90, so I'm not going to write. I also know 180, so I know values in the third quadrant also. Look at it. If I know sine of 0, I know 180 minus 0, I know 180 plus 0 also. One 180 plus 0 is 180, I already wrote. I know 180 plus 30 as well. Same as 30, but with a negative sign because in the third quadrant. I know 180 plus 45 also. Same value, but with a negative sign, third quadrant. I know sine of 180 plus 60 also. And I know 180 plus 90 as well. In the fourth quadrant, which values do I know? Well, if I know sine of 0, I know sine of 360 minus 0. I know sine cos of 360 minus 0. I know sine of 360 minus 30. I know 360 minus 45. And I know 360 minus 60. So do you see, if I know the values in the first quadrant, I know the values in all the four quadrants. If you graph these, you will realize what I'm trying to show you. So let me show you one thing. It's better I show you something with the help of an app. Okay, let me show you the sine graph. So I'm going to make theta 0, right? So as I'm increasing the angle, do you see the opposite side is increasing? And that's the value of sine. And it reaches maximum value at 90. Opposite side becomes 1, adjacent side becomes 0. Then it goes in the second quadrant, and again I form a triangle where opposite side is decreasing, adjacent side is going on increasing, and I'm reaching a value when adjacent side will be maximum. Where will that happen? At 180. And opposite side will be 0. So sine value has become 0. Then I go in the third quadrant. Again opposite side is increasing, adjacent side is decreasing, but both are in the third quadrant, so negative values. Right? If you just type GeoGebra trig graphs, you will get this out. At 270, again I'm seeing sine is maximum but in the negative direction and cos is minimum. And then again you see that opposite side is decreasing, adjacent side is increasing till it reaches 360, and then it repeats. Then it repeats. So the same thing will happen. So from 0 to 360 and 360 to 0, and then it's repeating forever. Let's look at the cosine graph. Cosine, how is it defined? Adjacent side upon hypotenuse. So keep looking at the adjacent side of the triangle now. So adjacent side is first going on decreasing. It starts with the maximum. and then it goes on decreasing till at 90 it reaches 0. Then again it increases, but in the negative direction. So an obtuse angle cos is negative. The triangle is growing similarly, isn't it? So the triangles will be similar inside that circle. We are looking at unit circle. Again, the third quadrant, and then the fourth quadrant. And once it reaches 360, it will repeat. Correct? Similarly, tan. Tan is opposite upon adjacent. Look at the tan value. When angle increases, sine increases, numerator increases, denominator decreases. So tan goes on increasing. At 90, what happens? Well, there is an asymptote because denominator is becoming 0. So undefined. Again after 90, I get it back. At 180, numerator is becoming 0, so 0. Again at 270, I'll have an asymptote. Again in the fourth quadrant, I come back and so on. Just pay attention. You saw that sine and cosine repeated after 360. But do you see sine, tan, sine and cos were repeating after 360. Whereas tan, you are seeing a repetition happening only after 180. Think about this. Why do you think this is happening? With that, I will stop here. You can go through sine and cosine rules and do more questions on this.